Number 2 on the test says use the limit definition of a definite integral, where f of x is this, to show what this works out to be. Now we know the integral of this is going to be x to the third over 3 minus x squared over 2. So we need to evaluate that from a to b, so we know what that should look like. So let's do this. This is going to be a lengthy, messy process. I won't give you one as messy on the real test, but you should be aware of how this works. So let's take a look at this. So we have the limit as n approaches infinity of the width of the interval. And the width of the interval, remember, is going to be b minus a, from a to b, split up to n intervals. That's what delta x will be. Excuse me. Width of the interval times the sum as I goes from 1 to n of f of this. So I got to plug this in for the x's. So it's going to be a plus delta xi quantity squared minus a plus delta xi. Okay. So we have the limit as n goes to infinity of the width, and we have summation of two things subtracted, and actually this multiplies out. I'm going to do that over here. A plus delta xi squared is going to be a squared plus 2a delta xi plus delta x squared I squared. And we got the sum of that and that, so I can split this up into separate summation ones. The sum as I equals 1 to n of a squared plus the sum as I goes from 1 to n of 2ai delta xi plus the sum as I goes from 1 to n of delta x squared I squared minus the sum as of a as I goes from 1 to n minus the sum as I goes from 1 to n of delta xi. Okay. This is the limit as n approaches infinity. Delta x, the sum of a squared from I going 1 to n. That's a constant, so we just got n of these constants. So times n a squared. Then we're going to have delta x times the 2a delta x is a constant, can be pulled out. So we're going to have plus 2a delta x squared times the sum as I goes from 1 to n of I. And we have a formula for this that I'm going to have to pull in here. Then we're going to have delta x times this, and this delta x squared will pull out, so we're going to have plus delta x cubed times the sum of I squared. And we have a formula for that. This is a constant, So we're going to have delta x minus delta x, sum of a n times, so that's a n. And we're going to have minus delta x squared times the sum as I goes from 1 to n of I. And we have a formula for that. Now, delta x has an n in the denominator, and that's important to remember now as I do this next step. So this becomes the limit. I'm going to take the limit at the same time. So this is going to be b minus a over n. The n's cancel, so I'm going to have b over a, b minus a times a squared. There would be no n in that, and so as n goes to infinity, this doesn't change. So that's the limit of this, because I could split this limit to limit of each part here. So this first term becomes just this. Now, this thing, the sum of this is n squared over 2 plus n over 2. I probably should have done one more step here, but let me see if I can get this. I'm going to move this down. B minus a times a squared. Now, I have delta x squared, which means it'll have an n squared in the denominator. Now, the n squared, let's cancel the n squared and make a half on this first part. So I'm going to have a half times a 2, which is 1. The numerator of this will be b minus a squared. And then when I take the delta x squared over, so it's b over n squared, there'd be an extra n, and as the limit goes to infinity, that will go to 0, so I can ignore that part. So out of this whole term, I'm going to get that. No n in this part, and so that's going to be limit as n goes to infinity is just that. Now, the I squared formula was n to the third over 3 plus n squared over 2 plus n over 6. And since I have a delta x to the third, I'm going to have an n to the third in the denominator. N to the third under this would go to 0 as n goes to infinity, and this would go to 0, but this would leave me with the n cubed canceling the n cubed, which would be a 1/3. So I'm going to have plus 1/3, and the numerator of the delta x is going to be b minus a cubed. So that's all that I would get out of this, since these two are going to go to 0. Now this one has a single n, that n will cancel, and so I'm going to have a minus a b minus a times a. And again, we have this formula, n squared over 2 plus n over 2. And this is delta x squared, so that'd have an n squared in the denominator, which would make this be a half, and this part, because there'd be an extra n in the denominator and n goes to infinity, would go to 0. So I'm going to have, see, x squared is b minus a squared, and we're subtracting this. That's the numerator of this, times a half. And hopefully I've got everything there. It's so easy to make an algebra mistake in this. Okay, so this would be a squared times b minus a to the third. B minus a squared is a squared minus 2ab plus b squared times an a, so this is going to be plus a cubed minus 2a squared b plus ab squared. And then I'm going to have this cubed. The binomial theorem is an easy way to get that. So we're going to have 1/3 times, this is going to be b cubed minus 3b squared a plus b 3ba squared minus a to the third. You can take the time to multiply b minus a times b minus a times b minus a, and you'll get this. We got it times 1/3, so we got plus b to the third over 3. The 1/3 cancels the 3, and minus b squared a. 1/3 times that would be plus 1ba squared minus a to the third over the 3. The 1/3 doesn't cancel on that one. Then we have minus ab minus plus a squared. And this would be b minus a squared is that again. So we'd have minus 1/2 of a squared plus 2ab over 2 minus 1/2 b squared. Hopefully I've got everything here and haven't made any mistakes. A squared b minus 2a squared b's. So now I'm at minus 1a squared b. And I've got plus a squared b. Those 3 will cancel out. All right. I have minus a cubed plus a cubed. Those are going to cancel out. I have an ab squared minus ab squared. Those are going to cancel out. I have b to the third over 3 minus a to the third over 3. That takes care of that one and that one, so I'm all the way to there. I got a minus ab, and this is 1ab, so those cancel out. I have a squared minus 1/2 of a squared, which is this is minus a squared. Oh no, a squared minus 1/2 a squared is a squared over 2 minus b squared over 2. If I factor a minus out of this, this becomes a minus and this becomes plus. And this should look like b in for x cubed, b cubed over 3 minus b squared over 2. That's what this would be. And then putting a in there, I get a cubed over 3 minus a minus, which would be plus a squared over b. So this works out to be what this would be. That's way too difficult for a test that would take you the whole period to do this and probably would make a lot of mistakes. I've worked on this one several times and keep making mistakes and finally got it right here. Okay,